Cool. Well, I think we can get started. Welcome everyone to our speaker event. This is Next Tech, co-hosted by Nano and You. So just a quick word about Next Tech. This is a national network of student organizations focused on nano and emerging technology. So I know we have people from Northwestern, UCSD, UVA, all around the country. So thanks for coming. We're putting on a lot of events like this throughout the year. So if you want to be added to like our listserv to get these events, you can scan this QR code, click this link. Actually, I'm not sure if you can click it. Or just message like your group at your college and we'll let you know what's happening. Here are some upcoming events. So it's a good time to be part of the network. Without further ado, I'd like to welcome Brandon Rodriguez. He's a NASA JPL STEM specialist. He'll be talking to us today. Yeah, take it away, Brandon.
How's it going, everyone? Thanks so much for joining. Really appreciate the opportunity to chat with you. My plan today is I have a very informal chat. I'm really just kind of hoping to hear what I can do to kind of chat with you guys about careers and research opportunities and just any kind of tips and tricks that helped me out as I kind of started my career. As you can imagine, it's a wild time right now at NASA. If you guys are aware, we land on Mars in 5 weeks. So that's what I've been up to. In fact, was up to until just a moment ago. Times have changed. Like I'm used to being on lab at JPL and working with my peers, and here I am with all this ridiculous technology to be able to work from home, a camera, microphone, this light, which is just way too hot and too bright, but they say is better. I don't know. So we're in a different world, so I guess whatever really, any tips I can offer, I feel like, who knows, like the apocalypse might hit and hopefully it's still valuable come next year. But I did kind of want to share just a little bit about how I got here and some of the really cool ways that you can open doors, right? I mean, the careers in science are just, I mean, it's every job now, right? And it's every success. So it's been really exciting to be a part of that. So maybe kind of just as a way to give you a little bit of background, I thought I'd share some slides real quick. So let me get those up for you. So I have a pretty wild career. I'm very fortunate. So I work, as you heard, at NASA's Jet Propulsion Laboratory. That's out in Pasadena in California, so just outside of LA. The best NASA site to work at, right? Everyone knows the other NASA sites like, Johnson and Kennedy, the ones in Texas and Florida, just from the movies and stuff like that. But they are not close to anything, right? Like for a reason. They're not near fun things. The Jet Propulsion Lab is in LA. It's just the best. So if you have to work at a NASA site, you want to work at one that's in a cool city. As a kind of a weird career, I actually have two lives. So I am both a teacher and a scientist. And I kind of got there from a really weird path that I wanted to share with you guys. These are my students actually from a couple of years ago. I taught high school chemistry and physics. I still teach high school physics here in Los Angeles. So I have easily the most spoiled kids because, they get to meet all these JPL scientists and I bring them all these cool toys and stuff like that. I've also taught college. So I taught college level chemistry and physics as well. So these are some of my first chemistry students. That's us in front of the Curiosity rover, which landed, I guess, in 2012 on Mars, and is, as you can see, very large, about the size of a Jeep. So I mean, some really amazing technology there. How did I start teaching and why am I here at NASA? Of course, you might be wondering. It's actually a kind of a new career field for me. So I actually am a chemist by trade. I worked for 8 years as a research scientist. I worked for a company called Dow Chemical. Really an amazing position. They treated me so well that I think I probably didn't even notice how well they treated me until after I had left. Really amazing job. So for years there, I worked on our alternative energy platform. So this meant making things like bioplastics. You can see on the top right, this is a picture of us in Brazil. So I was going to Sao Paulo a couple times for work and was looking at taking sugarcane into fuel, as I'm sure you guys know, right? Like not every country is as petrochemical dependent as we are. But this was just the start. This was kind of like the first step. Now, why stop at fuel? Why stop at ethanol for cars, which, you know, has a certain value, but why not go further? Why not make things that have an even higher value? And the way to do that is through biochemistry. So all of a sudden I was a biochemist, no training in that field. And as you can see on the bottom left, this is a metabolic pathway for some strain engineering we did to make propionic acid. So I know I don't have a lot of chemists in the audience, which is too bad. Chemistry is the best science. But it was just so wild. Again, I have no background in bio. I've never done strain engineering before. And you kind of start to work with these teams where you all contribute your independent skill set. You can imagine in like academia, your Venn diagram is just you. It's just one circle, right? You're all chemists. You're all looking at catalysts, right? You're all looking at a certain type of catalyst. You're all looking at a certain type catalyst for a function, right? And like you just get tunnel vision, right? Whereas in industry, it was very clear that you were a piece in a larger puzzle. That Venn diagram had many, many other circles, and you kind of were all overlapping on you know, what you contributed. This for me was really amazing because you learn to speak so many languages, right? I need to be able to communicate with the biologists that are doing this metabolic engineering. I need to be able to speak to the engineers that are going to design the reactors, because we're not doing this. You know, a lot of you guys do things, you know, in a lab, and you're looking at these tiny volumes. That doesn't make money, right? Private sector, you got to make in, you know, production scale. So how are you going to make this at, you know, 100 kilotons a year, right? So it was really wild to kind of be part of this. Something that I thought was really interesting that nobody told me coming through school was I've never worked in the lab. I don't put on the lab coat. I don't put on the goggles. That's not my job. That never was my job. My job was to be a brain. I was an idea man. So how can we kind of get these crazy things off the ground and kind of put the pieces together to make it fit and come up with a process? If you want to work in the lab, obviously great, right? There's a million jobs in the lab too. But that was never me. And it was really cool to see how there were careers in such different facets of science that weren't actually doing the science with your hands. So in education, actually, there's a really great experiment about this, and that's kind of what's happening in the bottom right, which is that we played this game on two levels, and it's called, you know, You Draw a Scientist, right? It's a pretty popular experiment. So if I gave young kids, anybody, piece of paper and some colored pencils, and I said, draw what a scientist looks like, everybody draws the dude on the left, right? Everyone draws this white stereotype, bald, crazy, mixing chemicals. That's what a scientist looks like, right? And that's dangerous for two reasons. First of all, from an equity perspective, nobody picks up a brown or black colored pencil, so that's a problem. People of color don't see that they can be scientists, right? If they see as scientists as white people, that's a problem. And then less importantly, you don't see a lot of people drawing a guy at a computer or, you know, talking to students at a university, right? So we kind of have these ideas that science is this kind of, you know, independent, you know, only using your hands kind of thing instead of an out in the public type of idea, right? Dow sent me everywhere, not just Brazil. I was going to Australia. They sent me to China for a year. I lived in Shanghai. I mean, it's incredible, the kind of opportunities you get working in science. So you know, obviously I'm here with I got the logo on, so I got to talk a little bit about NASA too. So about 5 years ago, I started working for NASA. This is the engineering model of the Curiosity rover. This landed on Mars before I got there, so this was before me. Here you can see it kind of with the skin off, if you can imagine, the casing off. And it's kind of hard to see, but like the arm is doing this motion. And so this is the hand with all the instruments on the top left, the wrist, which goes to an elbow, to a shoulder down on the base, right? You can actually see some of the wheels down there. These wheels, I'll tell you guys in just a second, they actually are not great for the longevity of the rover. So they started to get really damaged. The camera can take a picture of itself. So much like you guys, the rover takes far too many selfies, and it'll take pictures to kind of diagnose itself, right? Again, just like you do. So you can see that the wheels are starting to get damaged, and that's actually a result, if I have some, kind of physics-minded people in the room, the rocks, as it drives over, get caught in these chevron grousers. This is called a grouser. Tread, like in your car, goes in, a grouser comes out. And that shear stress of it getting caught causes punctures. So as a result, the new rover, the Perseverance rover, is not going to have this wheel design anymore. In fact, I have a cool job, so I get to keep one of these. So this is what the wheel looks like for the Perseverance rover that lands in 5 weeks. So you can see it's quite large. This is a big rover. It's about half the size of me. But you can see the design here now has kind of this wavy singular pattern. Pretty strong. It's about 40 pounds. This is titanium in the middle, aluminum on the outside, so that it's pretty resistant as it drives over the surface. I have a bunch of like crazy pictures if you want to talk about how it is that we land on Mars, and but I'll make sure that I go to questions first. But it really is just amazing to see this kind of technology as we test this out. So this is what we call the Mars Yard, and this is a device called Scarecrow. So Scarecrow is kind of like from like Wizard of Oz. It's the rover without the brains. So it's just for mobility testing. We drive over rocks and up hills to see if it gets stuck and do kind of testing for Martian design. I want to break for questions in just a second, but I'll finish the first kind of chapter of this story by again saying, I hope I can offer you guys a little bit of discussion and perspective on, I've kind of talked about 3 things, working in academia, working in industry, and working for NASA, which is definitely neither, right? Working for the government is a very strange middle ground, and there are pros and cons to all of those. It's not for everybody. But I will say, now being in science for 12 years now, since I graduated, like the ability to have a global perspective, I think has been the greatest gift that science has given me. So these are countries in red that work has paid for me to go to, which I think is just like the coolest thing. So from Hong Kong to see my boy Bruce Lee up here, to Japan and see the Torii Gates. This picture in Africa is of a lion, clearly, but I have an iPhone 4. So like you got to know how close I was to be able to get that picture. So that was pretty terrifying. More than anything though, probably the coolest trip I got to take was down here at the bottom. They sent me to Antarctica. So you can see, this is the ship you take as you sail to Antarctica. There is nothing there, right? So you take a small boat, and it's just probably one of the greatest moments of my life, because you reach land and there's just thousands of penguins everywhere. And the scientists are telling you, hey, make sure you stay professional, guys. Like, do not touch the penguins. That's not what you're here for. And everyone's like, of course, this is a work trip. But out of the corner of your eye, you kind of see one person like kind of touch a penguin, and then everyone got to touch a penguin. So it was just really cute to see. You can see their little baby butts sticking out of their little nests. It was really adorable. So again, careers in science just opened up so many doors, and it's just wild. And nobody prepared me for the diversity of careers, and just kind of the pros and cons of all of them. And I thought maybe that would be something for us to talk about. So let me take a break. I want to make sure this is guided to what you guys want to discuss. I'm going to kind of check some Q&A and make sure that you guys are getting everything you need. I see a couple questions, so let me get them for you. First question: is there a reason the wheels are made out of metal? Yeah. So Mars has no atmosphere, which means that radiation-wise, we're getting plastered, right? So there's nothing to stop UV radiation like there is here with the ozone layer. So rubber is already out. That's not happening, right? Like that would crack and pop immediately. Second of all, there's no roads, right? It's kind of silly to have to say that. Like, if you think about it, right, like the terrain is like driving off-road through the desert, right? So as a result, you really need something that's tough, that's not gonna pop or get busted. That's why we use metal. But aluminum and titanium, very, very strong, very, very light. You know, it's hard to send things to Mars. So lightweighting everything is really key too. Let's see, Ale asks, my dream is to have a job, pays me travel. Do you have any advice for how to get started on the path? Yeah, absolutely. So it really depends what you're doing. So if you are in academia, if you want to be like a research professor, work at a university or something like that, your travel is going to be travel to conferences, and that's it. I'm not saying that's bad. Everyone loves, like, because conferences are good places. They're in like Hawaii and stuff like that, right? So that's not the worst. But you're not typically collaborating over a distance, right? And it's kind of crazy. Obviously now with COVID, nobody's traveling, but it's obviously cheaper to do a call like this, right? Nobody offered to fly me into Chicago to talk to you guys, right? So less and less you're seeing academic jobs that have this type of travel. Industry is different, right? So if you work in the private sector, for example, when they sent me to China for a year, there's a reason I needed to be there. The culture of China is not, first of all, there's time difference, obviously, but even if not, the culture is relationship, right? It's not like the kind of, you know, US East Coast kind of mindset where time is money, we got to go. You would go to meetings in Shanghai and you wouldn't talk about business at all the first meeting, not at all. It was about getting to know each other. What do you care about? Let's go out for a drink. Let's go out for dinner, meet my family. So typically jobs in industry, they are a little bit more collaborative on an international level because other cultures really care about your presence, that you got to be there and be part of the team, not just some person on the video, you know. So private sector is probably your best bet to go. The other thing is, and this is, I mean, I don't mean to be crass. I just want to be honest with you guys. Private sector pays a lot more, right? I mean, I took a huge pay cut to work for NASA, huge. So you're going to travel a bunch if you're cashing that check. You know, private sector pays really, really well. Let's see. My man Josh asks, how do scientists and engineers collaborate in projects at JPL? Yeah, and this, I kind of mentioned with that kind of like Venn diagram metaphor, which is, you know, probably weak, but if you get what I'm trying to say, there is no person alive at JPL that knows how to do everything. Doesn't happen, right? So if you're working on a rover, like let's imagine what you're doing. I already talked to you about wheel design. You got to write the computer code. Not just to drive the rover, but to land it. You got to work on the trajectory. You have to launch. I'm not a rocket scientist. I don't know anything about that stuff. Now that's just the rover itself. What about the science it's doing? There are so many chemists working on this rover, right? Pixel uses X-ray and Raman and UV to look for biosignatures. So we're looking for biochemicals in the rock structures there. MOXIE is a device that's catalytically splitting the CO2 atmosphere into oxygen to see if we can make breathable air on Mars. So, you know, all these different jobs, you know, it's kind of crazy. Nobody knows all the things. So what do? Like I said, you got to learn the language. If I'm a chemist working on MOXIE, the engineers do not care about whether I'm using palladium or rhodium to dope the zeolite. They don't give a crap about that, right? What they care about is, how much energy do you need? What temperature does it need to run at? What kind of fail-safes does it have? How much space in the rover do you physically need? Because everyone's competing for space in that compartment. So you just kind of learn what people care about, and that's how you talk to different fields. So yeah, I'm telling you, if there's one thing I learned, it's just like, you know, no one tells you about this. No one tells you how different these jobs are and your coworkers, and you got to learn how to speak to them. So I thought that was really cool. Cool. Next one. Can I talk about my daily schedule and balance all the interesting things? Okay, first of all, I have no work-life balance, none, right? Like I am a sociopath and I need help, right? So like I said, you know, I do this education side as well. So I'm teaching in the morning before I go to work, which means that I have to make up those hours. Now, obviously not everyone needs to do that. That's just a kind of a choice of passion. I just think it's important. Doing events like this, I just think is important so that you guys have some perspective. But my daily job at JPL is also really awesome, I gotta say. Maybe I know I got other questions, but I wanna show you a few pictures of what it is I do on any given day. So I'm very, very lucky because I get to spend, effectively, you can do two jobs in science at NASA. You can be what I call like single focus deep dive. You're gonna be the expert at a thing, and you're gonna work for 20 years on that thing, right? Like a buddy of mine who worked on the Cassini mission, which took all these amazing images of Saturn. That was his job, right? He designed it, he built it, he launched it. Like that was it. Like that's what he was on that mission for his whole career. I don't like that. I'm not patient enough. I like pace. I like things to go. So I'm kind of in that second tier, which is I work on things for like a year at a time, and then I move to a different project, right? So they kind of throw me around into different cool things. One of the cool things I got to work on in 2019, if you guys are aware, there are 2 moons in our solar system that are literally floating oceans, right? Everyone talks about, oh, is there water on other places? There's water everywhere. Earth is not special, right? Europa and Enceladus, which are moons of Jupiter and Saturn, respectively, are giant oceans in our solar system, not even far away, right? This is just in our backyard. Europa has more water than all of Earth combined, right? It's enormous. So you can see, this is a picture of it, actually. And obviously space is cold. As you know, in Chicago, Lake Michigan doesn't freeze from the bottom up, right? So you get ice on the top, but all that water below is liquid. So there are, because of the gravitational force of Jupiter pulling on it, the ice cracks, and you can actually see water spraying out into space, right? So one could imagine, instead of driving a rover on Mars, which we know is dead, it had life before, but like is dead now. Why? I mean, Mars is cool, don't get me wrong, but like, wouldn't it be much cooler to look in an ocean? An ocean has much more promise for life. Think about Earth, right? Where is life? Life is in the oceans. Life came from the oceans. So what if we could take a submarine, inject it through these cracks, and like swim around instead of drive around? So I got to work on that. Actually got to work on that with this guy here on the right, if you're in the know. His name is Bob Ballard. He's the guy that found the Titanic, and he has a research vessel. So this is a kind of a submarine. It's called an ROV, a remotely operated vehicle. There's one handsome scientist shown for scale. So you can see just how big this is. And the principle was, could we, test this for like an alien ocean? We put a robotic arm on the front of it, to kind of like interact with rock samples. So here you can see it from above. And here is just a close-up of that. So this is like some pillow basalt, and the rover, the ROV is gripping this and breaking it to see if we can collect rock samples in these alien oceans. And it's just wild to me. My boss used to tease me and say, like, why do you want to work on this? Like, all that's going to happen is your submarine is just going to like have this video footage of like a shark just like closing its teeth around it. And I was like, are you kidding? That'd be like the greatest day of my life. Like getting eaten by alien shark is the best way to go. And it really is exciting. There's just so much cool life down there, right? Remember, like we're 2 miles or 2 kilometers underneath the water, right? We're somewhere where light has never been. So creatures down there that have never seen light or other people before. So like these giant jellyfish. This is 10 centimeters for scale, just for perspective. We were collecting coral samples down there, deep sea coral. And one of the cooler things we saw, there's only been a couple of these ever seen. This is called a Deepstaria enigmatica. So this is like a jellyfish, just crazy. It looked like the ghost from Pac-Man kind of swimming around.
Brandon, quick note.
Yeah.
I think your screen's been not being shared for the past few slides.
Oh no, just for the past 2 slides? Okay, let me show you.
I think like when you started talking about like the moon.
Yeah, thanks for interrupting me. Let me show you.
Okay, cool. Yeah, we don't want to miss any of this.
Is it good now? Can you see it?
Yeah, awesome. Thank you.
Cool, cool. So I just kind of started and restopped it. Hopefully it's good now. So here's the Europa, the moon I mentioned. Here are the cracks, you know, showing that water coming out. And then here you can see, here's me and Bob. Here's the ROV, the remotely operated vehicle. Here you can see it from above with that arm that I mentioned ripping at the basalt. And then just some of the cool and crazy life that we saw down there too. Right, there are coral samples. That's the deep star, yeah, enigmatica, it's crazy jellyfish. Really neat. And of course, like you get to, you know, everyone wants to hear about like sharks and squid. There's a giant squid down there. It was really, really cool to see. It's a vampire squid is the name of it. So it was really neat. Same kind of thing. You know, let me pause for a second. Again, let me tell you, when you look at like jobs again, you know, who is on board this ship, right? You know what I'm saying? Like, it's not just chemists, right? Because that ship takes a ton of money and time to operate. So it's not just a couple NASA people. You also have people from National Geographic. You have people from NOAA. People are looking at oceanography. They're looking at climate science. They're looking at growth rates of those coral samples that I showed the picture of, right? Like, so that you can see, you know, what ocean acidification is doing to the species down there. I mean, it's just everyone's collaborating. Such weird groups kind of all come together. So it's pretty wild. So let me see. I know I kind of missed a couple questions, so I'll make sure I got them. Yeah, sorry, the images weren't showing up, my fault. Let's see. So Jeremy says, when I left Dow, also considering academia, government stuff, what was your favorite and least favorite thing for each? Yeah. So, you know, I mean, this is just personal, right? It's totally everyone's different call. You got to pick your poison. There's no silver bullet. Private sector, for sure. The perks were things move really fast. I liked that a lot. If you're answering to shareholders, right? If there's money, if there's a bottom line, we don't have time to like just play around. We're not doing research for research sakes, right? We're doing research for money. We gotta have an end result, a product to sell. So that kind of pushes you. So if you're the kind of person who wants just to explore, just for exploration's sake, academia is your place, right? Now, of course, the downside is you got no money, right? If you work in academia, you're kind of scrounging dollar for dollar. So you're writing grants. You're trying to like team up with someone who's already established so that they can kind of get your name in the game. You got to pray to God you get tenure someday, right? So that you can at least do some of the things you want to do. But someone's always over your shoulder, right? How much money are you spending? How many papers are you putting out, right? You got to, you know, so academia kind of, it's you have the creative control, but you got to beg and steal and cheat and get the money, right? And sell yourself to get it, right? So pros and cons there. The flip side for working in industry was, you know, again, it's kind of like the other side of that coin, which was there were days I just kind of didn't care, right? Like, but it made money, you know? So they would be like, hey, we want you to work on this project. And I was like, I don't care about that project. And they're like, that's not important, right? We don't care. We don't pay you to enjoy it. We pay you to make us money, right? Or, you know, I remember like there were times where they were tough, you know, if the economy was in bad shape, like, right, you know, now if you work for a company like Exxon and oil prices are low, then you got to worry about, are you going to get fired? They take away a bunch of your job perks. Are you going to get your bonus? I remember one year they took our coffee away, you know, it's kind of like, how much money are you really saving by taking the coffee out of the coffee room, right? So it's little things like that. The last one is working for government. And like I said, it's kind of its own beast, right? I love working for NASA. I mentioned I took a huge pay cut to work for NASA, but I love what I do, right? I'm an old man now. You know, I got a car, I got a house. So like I could afford to say, I really just want to do what I love. And that's what NASA has really offered me. So it's been really cool to be around some of the greatest minds in the world. You know, we're located right next to Caltech. And the number of just like, you know, Nobel Prize winning scientists that just come through and say, hey, or you see them out in the, we call it the mall, like the courtyard. And I'll be like, you know, man, when the gravity wave detection kind of came through, I was like, you know, this guy was all over the news. And I was like, buddy, I'm sorry to interrupt. Can I get you a coffee? Can we talk a little bit? Yeah, man. I got half an hour. So like, you're just around the most cutting edge science. And I think that's probably my favorite part. Of course, government jobs also mean just slow pace and so much oversight. And then, it's like, I can't accept an Amazon gift card more than $10 because that's like quid pro quo, like things like that. So yeah, pros and cons for everything, for sure. Someone asked how I have the opportunity to teach and work at JPL. Yeah, if you're looking to do that, let me tell you, you got to think about establishing yourself in both fields. So like I said, I worked in research for 8 years first, then I started teaching, and then I got cold called by NASA. It was the weirdest experience. And they said, we want you to do both. We're going to let you do both. And I was like, I'll be right there, right? Like I dropped everything. If you're looking to live in both worlds, don't think you're going to get that job until you already establish yourself in both worlds, right? So that's it is tough. And that part can be kind of tough to get over. I'll warn you too, that I'm at a point in my career now that for me to continue to advance, they want you to pick one or the other, right? So this is fun to do, and it's just something I enjoy so much. But 10 years from now, 20 years from now, they are going to expect, hey, you had your fun. It's time for you to focus on chemistry or on education. You don't get to do both forever. So you see a little bit of divergence as you go, but I want to stay in this middle ground for as long as I can. So it really is a dream job, right? But long term, if you want to climb a ladder, it's harder to climb 2 ladders simultaneously, if that makes sense. Ale is asking, do I have advice for how to find opportunities in college or right out of college? Yeah, absolutely I do. This is old man Brandon talking. I know that COVID has obviously changed. So like assuming that we kind of go back to a semi-normal state. Kids these days, right? You young kids, the biggest problem is you sit back, you're on your computer looking for job postings, and then you're like, well, why didn't I get it? I'm so good. Nope, no, don't do that. Go down the hall with your resume and introduce yourself, right? Like, do you know how many emails I get every day about like, hey, I would like a job at NASA. I don't know you. I'm too busy to like look you up and research you and be like, oh yeah, this is the one, right? No, I don't have time for that. So like, think about how many requests your professors or these companies are getting. Why would they pick you, right? So the answer is, be a human being. Go to them and say, hey, what's up? I'm interested in getting started. This is who I am. This is my resume. If you got anything, let me know. If you don't, cool. But the second you do, please remember this face, right? Another thing, just again, grumpy old man talk. I feel like kids are crazy entitled now. Everyone thinks that they're going to be coming in at some great job. I remember my first couple years at JPL, I showed you guys the Mars yard. We took interns for the summer, paid interns, right? They were making thousands of dollars a month. And their job was to, we would give them a picture of Mars and they would have to recreate the terrain, like get the rocks that look right and the right distances so we could drive over them. And I remember these kids being like, I can't believe I got to be out here in the sun moving rocks. And I'm like, I worked fast food, right? Like I worked at Sonic Drive-In. You work at NASA getting paid 3 times as much as I ever did. So like, come in humble, please. My first internship was my freshman year of college, actually. And I went to a university. I went down the hall and I said, I will wash dishes. Pay me $0, right? I'll use that time to just kind of talk to some of your students, learn a little bit of something. And that turned into a paid internship, right? So get your foot in the door, be humble, and just kind of get your face out there, right? Don't apply a lot, talk a lot, go meet some people. I hope that helps. I know that's an old man rant, but I'm an old man now who's hiring, so you should listen, right? Anything I wish I knew in college? Ooh, I shouldn't be telling too many stories, but Yeah. Like, I guess probably the first thing that comes to mind is you definitely want to understand what a future career looks like. So I didn't even know what the GRE was. I didn't know what like grad school looked like. Do I need a master's? Do I need a PhD? I didn't know that stuff. Pretty much now for like any science job, that's not true. Like engineering is definitely different, but like you need another degree than you'd think. You know what I'm saying? If you want to work in research science, chemistry, biology, stuff like that, now you need a doctorate. You got to have a doctorate. If you want to be an engineer, you should probably get your master's. It will help. You should get your master's. It's just competitive out there, you know. So you find out what you need to do, right, to get to that next level. So do a little research, right? I'll also say to Anonymous, please enjoy college. Go nuts. Don't get yourself in any trouble you can't get out of, but like being an adult sucks, right? I got a mortgage, man. It's not fun. I got a checkbook. I'm not trying to do that stuff. So please enjoy yourself, but make sure your resume looks good while you have the chance to. Let's see. And last one, if we're looking for interdisciplinary jobs, would you rather trying to specialty and then trying to work towards? Yeah. So Alex, I think you have the right idea. Yeah, kind of start in a thing, but then like when you get there, always be looking on how you can branch out. Like collaboration is key for sure. You will never be a solo scientist in your little alcove. This is not the 1600s anymore, right? Like it's not, Copernicus sitting in a tower. This is not how it goes anymore. So establish yourself as good at a thing. Talk to someone else who is good at a thing. Find something that you're good at together. Once you got two, find a third. You know what I'm saying? And just kind of branch out. I'll tell you, for example, I always have to be learning just because times change, right? And I want to stay up to date with everything that's going on at NASA. I'm a chemist by trade, as I mentioned. But I went to JPL a couple years ago and said, hey, I gotta learn, right? I gotta catch up. And they sent me to university, and I got to take a couple classes in coding. So now I can like write in Python pretty decently, right? Not well. I'm not gonna start writing code for the rover. But when a computer scientist talks to me and shows me code, I get it. I understand it, right? So, like I said, you establish your foundation, and then always be looking to branch out. Always work on your professional development. It'll make you look good. It'll make you qualified for more jobs. All right. And I see I got one question over here on the other chat. I got two. Someone said, "What are these creatures?" But yeah, it's crazy out there. The ocean is nuts. And how do you apply for specific postings if you don't know yet? Does NASA have rotation programs? Yeah. So let me put a link in the chat for you. So this is the internships page for JPL. Intern and apply. I'm going to copy this in over here. And I think I can select everyone, right? Panelists and attendees, yeah. Okay, I hope you guys can all see that. Let me know if you can't in the Q&A, and I'll share my screen. So this is the JPL internship. This is just JPL, right? I don't know how the NASA other ones work, but this is how my site works. Tons. We take literally thousands of interns every year. Now, again, this is not your best year to apply because JPL is closed. That's why I'm at home instead of at my office. But we take literally thousands of interns. So tons and tons of jobs, whether it's for 6 weeks in the summer, whether it's a year-long thing, if you can be nearby, all paid paid well. Again, I'm a little throwing a little shade just because it must be nice. So yeah, tons of really great opportunities. That's where I would start. I'm sure you guys want to know, kind of we were talking about how do you get noticed on these types of things. I will tell you right now, as someone who goes through these resumes, I think like the 4th or 5th question down is what like extracurricular science activities are you involved in? And if you leave that blank, I'm putting yours in the garbage, right? Like that's just a fact. So if you tell me, oh, I got a 4.0, I got a 1600 SAT, all this stuff, I do not care. I'm not interested. I'm around smart people every day. It doesn't impress me to see smart people. So what can you do, right? So if you tell me like, hey, you know, I got this internship, or I lead a robotics club or something like that, that's much more impressive to me. That shows me that in your free time, kind of like I was saying to Alex, you're doing more and more to get better and better. So that's probably my number one tip for you. Let's see, my friend Siren says, if I don't have contacts at JPL, that's okay. You probably shouldn't. If you did, like, you wouldn't need me around, right? What can I do to increase my chances? Yeah. So that's how I would look at it. Really, is please do not talk about how smart you are to someone who works at NASA, right? I mean, I don't mean to be like, you know, I don't mean to be like gloaty or something like that. But like, you think we don't got smart people? You know, what are you at 18 or 20 years old gonna teach us? You know what I'm saying? So like, you're not smart. You're not smart yet. So show me that you can become smart. Show me that you can do something incredible over time. How do you learn? How do you seek opportunities? How are you developing yourself professionally? That's far more impressive. I hope that answer is not like offensive. It feels like a silly answer to give. I feel like my boss is gonna be angry about that, but. Let's see. So someone says, have you ever thought about transitioning or working in the private sector? Yeah. So it's, I have thought about going back, right? I have thought about it, but when I sit down, I talk to my buddies that still work in the private sector, and I ask them about it. And you know, really, to be honest, the only thing I miss is the money. That's it. That's the only thing I miss is the money. And that's not enough to leave this. I was in a conference this week, presenting my research. I'm doing a new project now. I'll show you guys in just a second. And it's cool. It's just cool. You know, it's kind of cheesy, right? But like, what's the old saying? Like, if you love what you do, you don't work a day in your life. Like, I get it. And I want you as young people, for sure, get that money first, right? If you guys are looking at like graduate college and then work in nonprofit, no, don't do that to yourself, right? Go out, get a nice job, take care of yourself, of your family, get stable, and then go do something you love, you know? Because you don't want to work for 40 years just for a paycheck, you know? So I'm really happy where I am. I really love it. I'll show you guys real quick just what I was presenting on. So this is my new project now. It looks like I'm sharing. Now I'm just nervous, so I'm double checking. We're good on sharing. Okay, cool. Good. All right, so this is a nebula called IC417. It's 2.3 kilolight years away, and I just think it's a beautiful picture. It's in the direction of what's called the galactic anticenter. So if you think Big Bang happened here, if you look this way, then this should be the youngest part of the universe, right? So the middle of our known galaxy, if you look in the opposite direction, you should be looking at the youngest part of our galaxy, right? So what we're looking at here is these orange dots that you see in the middle in this band are stars that are just turning on for the first time, right? So this is looking at how young stellar object formation kicks into fusion to make stars as we know them. So what's happening here on the right, you can kind of see like a cup, like a bubble. So there was an explosion and all this particles, right? The particles of this nebula are moving like this. And the, you know, what's the best word for this, right? All of that motion and contact in between all the particles of that nebula have caused that accretion of particles and allowed for stellar formation to start. So this is what I'm working on now, is we're looking at, can we actually watch a star turn on, which is really neat. So I get to use like the Spitzer telescope, the Hubble telescope, and some of these devices to look at this data. It's pretty cool. Cool. Anything else that I can answer for you guys? I got one more question here. Let's see. It was a long one. Oh, my man making me chapter 1, chapter 2. So let's see. Doing mechanical and neuroscience. Cool. Or nanoscience. My bad. And done research a bunch of stuff. And I still don't know my passion. Yeah. I hear you. Yeah. So yeah, if you're a senior and you don't know exactly where you want to land, I think that's okay. You know, like generally when I'm looking at people who apply, if they tell me that they're like, especially with engineering, like a bunch of people, we get a bunch of like aerodynamics guys, but like I can put you in electrical, I can make it work, or I can have you learn some things to get to a place where you're working on both, right? So like the thing is, like, I think in school, they tell you that you live in these little boundaries, right? So like, are you in nanoscience? Are you in biochem? Are you a civil engineer? Are you an electrical engineer? But like, that's just not how it works in the real world, right? So like I said, like I'm a chemist and I'm looking at stars turning on. What the hell do I know about that, right? So you kind of find that you don't have a clue where you're going to end up, right? If you had told me I'd be teaching high school, I would have laughed in your face. Like, I cannot afford to do that, and I hate kids. So like, why would I be doing that? So you know, I mean, just stick with what you're good at, get your foot in the door, and let kind of. There's no such thing as a 5-year plan or a 10-year plan. You don't know. Things are too uncertain. So one day at a time, I think. Anything else? Oh, let me see over here. Sorry, I got so many windows for Q&A and. Okay. Something to impress a hiring manager. Okay, here's a pro tip. This is a job pro tip. This is not just a me thing. We're all trained to do this. Be very careful about when you use I versus we. Okay, it sounds so stupid, but I'm telling you, you will come off very differently. If you say I did this, it would be insane if I sat here and told you when I launched to Mars, when I did this, when I did that, you're gonna be like, for real? Did you do all of that? Right? You look too egotistical. When you say we, you show that you're on a team, but you still want to actually identify yourself as an integral part of that team. So using I and we with a reasonable balance is very appealing in an interview situation, because it shows that you know what your strengths are, but how to use those strengths with other people. Number one pro tip you can have in an interview, for sure. How did I get my job out of Dow? Okay, so this is the perks of working in science. They come to you, right? I have never applied to a job since graduate school, never. They come to you. They come to your school if you are like in a doctoral program, and they say, how can we get you? Do you want to, you come and they talk to you for like 15, 20 minutes, and then they fly you out, right? If you made it. So like, you don't go and hunt for a job anymore. NASA, like I said, they called me. I didn't apply. So once you're there, like once you're in for life. It is amazing. It's really cool. So that's one of the perks of science. I think they do that to kind of like battle against this kind of like pre-med mindset, right? Of like rigorous competition and cutthroat and all that stuff. Like if you're in science, you're valuable and they want you. They're going to come find you. So you're going to see at your university, there's a lot of recruiting efforts that will go on. I know Northwestern does this as a fact. So they will come to you and interview you there. Let's see. I want to make sure I get these. We got 3 more. Seems like drastic changes in careers. What's the decision process? Yeah, like I said, like I'm very fortunate that I had established myself first, and that allowed me the privilege to kind of roll the dice, right? I remember one time my buddy and I, they were trying to poach us this nonprofit. I'm sorry, not this nonprofit, a small startup. So it was a chemistry startup company, and they only had like 50 people, and they were like, hey, you can be on the front end of this, right? Like this could be, you could take this off the ground. And I was like, wow, that sounds pretty cool. And we talked about it. But I was like, Nah, I want health insurance, right? I want a 401k. I don't want to worry that this idea gets bought and then they decide to bury it, right? Or like they move it to another country or something like that. So, you know, you like I kind of said a couple times, establish yourself first, take care of yourself financially, and then once you're in the position of comfort, do what you love from there. Then you can take some risks. And if things don't work out, you know, like again, it's a job in science. You're going to be fine. You're going to be fine. If you want to apply for a job that's not local, how can you talk and make that human connection? Yeah. So obviously that makes things a little tougher, right? So when I said like walk down the halls, I mean like this is how you should get started, right? So like if you need your resume lines to have some opportunities, some careers on there, that's local, right? Because there are jobs that nobody's posting. And again, if you go to a lab and you say I'm going to wash dishes for you, and you know maybe just kind of hang around your grad students, they're not posting that job, right? They're just saying, yeah, man, whatever. I don't care, do it. So like there are opportunities that just aren't online. Obviously now, again, in a remote world, it is harder. It is harder. And it sucks because you become a number, right? So if you apply for a job at JPL, like there's so many of you, and it's computerized too. I hope you guys know this, right? Like, it's not like I look at all these and I read all of your essays and I'm like, wow, I'm so moved by this, right? Like, that's not how it works. When you apply to graduate school, an algorithm gives you a number, right? Like they say, oh, your GPA times your number of job experiences times, you know, like it's a mathematical equation. You think universities go through 100,000 applications? So it's kind of crazy. Yeah, it's tough. It can be tough out there. But yeah, think locally, please. Like if you're just trying to get on the map, you start down the hall, establish yourself, let your network kind of carry you. That professor likes you, maybe that professor has a friend, right? And you got to work the game a little bit that way. Let's see. So I'm almost out of time. Let me take this one more. Challenge of improving from the Curiosity rover to Perseverance rover. Yeah. So if you can imagine, the Curiosity rover really was a geology experiment. So it looked at rock samples. It tried to understand what are these rocks. Oh, it's clay, so there was running water. You know, that kind of science. Perseverance rover is now a biochemistry rover. So the instruments aren't, oh, is this, you know, sandstone versus granite? Now it's, is there microbial life in those rocks, right? Is there something that would phosphoresce or something that would show up in the UV? It's going to drill, so it's going to pull core samples out. Before we used to just powderize it, and you would zap it with a laser, and you would look at the X-ray, the spectra that came off that. But now it's actually going to pull rock samples out from the ground and look at the actual stratigraphy, right? So how has the samples changed over geological time? So it's much more advanced. It's really pretty impressive. And that's, you know, that's 10 years difference. So it's not even. So it's kind of crazy how far it's come. So I got to stop there. I hope everyone's okay with that. I got a 5 o'clock meeting back to back. But I hope you guys found this helpful. I hope it does help at all. I'm happy to put my email address in here. It does not bother me at all. Let me do that for you. You guys can reach out anytime. Am I going to write a letter of rec for you? Nope. You know, but if you want to talk about like careers and paths and you have burning questions, please just let me know. Because you know, I was just like you guys, right? I felt that strain of getting started, and there's so much I wish I learned, and I'm always happy to talk about it. So thank you guys so much for your time. I hope you enjoyed.
Thank you. That was amazing. That was fantastic. I think I'm speaking for everyone saying thank you.
Cool. Reach out anytime. Yo, and like little things too, like, you know, even though I'm an old man, I'm a kid at heart. You send me like your mailing address, I'll get you like some NASA swag, like stickers, stuff like that. Anything you want. I'm just here to help, and I appreciate your time, and hope you guys are going to be successful in the future.
Thank you so much.
Cool. All right. Have a great one, guys. Take care.